Hi everyone, I am Dr. Deva, enrolled in Statistics course, and today we will be discussing a revision or remedial, or it's a very quick review for your preparations. We will be starting from binomial, and then we will move to Poisson, normal, sampling, one sample, two sample, t-test and z-test, and then chi-square ANOVA, then correlation regression will come on. So all these things we will be discussing, and don't forget it's a very quick review. Follow to me. I will not be repeating as it is in a recording. Let me move. An identical computer components are shipped in the boxes of 5. So the value of n is 5. The value of n is equal to 5. It is less than 30. I told you this is the threshold for large and small sample. So it is a small sample, and hence it belongs to binomial distribution. Like this only we have to determine whether it is binomial or Poisson based on either it is a small sample or the large sample. About 15% of components are defects, so I am writing P is equal to 15%, 15 by 100, or you can write it as 0.15. 0.15. The boxes are tested in a random order. What is the probability that the randomly selected box has only non-defective components? So let me write the formula for binomial distribution. It is ncx into p power x into q power n minus x, with x is equal to 0, 1, 2, 3, etc. till n, and I have to calculate only non-defective, which means that I don't want any defectives. Again, I don't want any defectives, means 0 defective. So what is n? 5. C means combination. X, it is 0 mentioned over there. What is p? It is 0.15 whole power x. The value of x is 0, and into q. The value of q is 1 minus p. So 1 minus 0.15, remaining 0.85. So it is 0.85 whole power n minus x. What is n? N is 5. What is x? 0, which is equal to, use your calculator and get your answer. Write the R programming over here. So what is the R programming? The R programming is which distribution it is? Binomial. So it is binom. What we are discussing? Binomial distribution. So it is D. What is the first one? The x value. What is the x value? 0. What is the next one? Size. What is the size? Size means n. The n value is 5. Sorry. The n value is 5. The next one is p. The probability value. The probability of success is equal to 0.15. That's the command for the binomial distribution, or programming for binomial distribution. So if it is any other question, then act accordingly to answer for those questions. And it's a Poisson one. If 2% of the components produced by the machine are defective. So what is the meaning? So if 2 out of 100 components produced by the machine are defective, same, right? 2 out of 100, which means the 2%, right? So in a box of 200 components produced by this machine, write an R programming to find the probability that exactly 2 are defectives, find the mean and variance. So here it is lambda. Lambda is equal to, it is given, it is 2%. Lambda is equal to n into p. So n is 200. It is given here. N is 200, and p is 2 by 100. So the value is 4. Cancel these two, and the value is 4. So you please check the question, either whether it is given directly the lambda value, or they have given n and p to calculate lambda from your side. And let me write the formula. Even though it is not in the question, it is e power minus lambda into lambda power x by x factorial comma x is equal to 0, 1, 2, 3, etc. There is no infinity level. It is still infinity, and p of x is equal to, what is the question? Exactly 2 are defective. So it is x is equal to 2. E to the power minus, what is the lambda value? 4. Lambda value is 4 power x. What is x? 2 divided by x2 2 factorial, which is equal to, write your answer from your calculator and write an R programming to find the probability. So which distribution we are studying? Poisson. Which distribution? Poisson. So it is Poisson. And which distribution we are studying? We are studying Poisson distribution. So it is d Poisson. So what is the first one? It is x. So it is x is equal to 2. What is the next one? The next one is lambda. Lambda. I told you many times, just type 3 letters and let the R Studio to respond, and then you can type enter to get into that. So what is the lambda value? It is 4. Execute this and get your answer. And what is the next one? Mean and variance. The mean and variance is for the theory, and it is mean is equal to lambda is equal to 4. For a Poisson distribution, mean and variance are same, and hence the variance is also equal to 4. We'll move to the next one. It's a normal distribution. It's a continuous distribution. The binomial and the Poisson are the discrete distribution. Normal is a continuous distribution. The speed transfer from a server on a campus to a personal computer at a student home is on a weekly evening is normally distributed. They will be given normally distributed or bell-shaped distribution with a mean of 60 kilobytes per second. So it is mu is equal to 60 with a standard deviation of 5 kilobytes. So sigma is equal to 5. So it is given. It may not be given also. Okay, even if it is not given, it is our duty to find these values. Predict the probability manually that the file will transfer at a speed of less than 70 kilobytes per second. So what we have to do? Less than 70. So write the formula. Z is equal to x minus mu divided by sigma. So what is x? We don't know. Just keep it as it is right now. Minus mu. Mu is 60 divided by what is sigma? It is 5. What we have to find? Probability of x is less than 70, which is equal to probability of, what is the z value corresponding to 70? What is the z value corresponding to 70? So if x is equal to 70, which implies z is equal to 70 minus 60 divided by 5 is equal to 2. So it is less than 2. So 2 means it is 2.00. We have to find which is less than 2. So it is the normal distribution. In the normal distribution, it is the middle one, and here it is z is equal to 2. The question is less than. Less than means all this area plus this area. This area. So it is minus infinity to 0. All are z values. So what is our objective now? So p of z less than 2 can be written as p of minus infinity less than z less than 0 plus probability of 0 less than z less than 2, which is equal to probability of 0 less than z less than infinity plus probability of 0 less than z less than 2, which is equal to 0 to infinity, one side, this is 0.5, 0 to 2. How to find 0 to 2? 0 to 2.00. So move to the normal table. 2.0 with 0. 2.0 with 0. 4772. So it is 0.4772. Answer is 0.9772. Okay, so get back to the program. The program is, it is a normal distribution, and hence we will be using p norm. It is not d norm, it is p norm. P-N-O-R-M. Okay, N-O-R-M. P norm. P norm of the first one, q is equal to 2 value, it is 2, and I'm sorry, q is equal to 70. Okay, mean is equal to 60, and standard deviation is equal to 5. How much is standard deviation? Yeah, it is 5. It is 5. Execute this. If you execute, you will be getting the less than frequency. The less than probability. So if at all they asked this part, then use 1 minus. Then you will be getting the rest of the part. So in this way, you can try to solve the rest of the options given in the booklet, and we will be moving to the next one. So how many types of alternate samples are there? There are 3 types. What is that? One is greater than, another one is less than, another one is not equal to. Which can be the null hypothesis from the below. The null hypothesis is always mu1 is equal to mu2, because all the rest become the alternate hypothesis. So the next one is confidence interval. In the confidence interval, let me go to the question directly. To ensure the efficient usage of a server, it is necessary to estimate the mean number of concurrent users. According to the records, the sample mean is given and the sample standard deviation is given. Okay, and construct 90% of confidence interval for the mean number of concurrent users. What can be the margin of error? So we want to construct a 90% of confidence interval for mu. The n is large. So what is the value of n? The value of n is 100. So this 100 is greater than 30. Since it is greater than 30, this is a large sample. Since it is a large sample, this belongs to z-test. And this is the formula for the CI, the confidence interval, and this is x bar minus z alpha by 2 is a single number. You have to calculate from the table sigma standard deviation and n the value. So it is x bar. What is x bar? Sample mean. It is 37.7 and 37.7 minus and plus sigma by root n. What is sigma? 9.2, and here it is 9.2. It is based on the concept that if you don't know the population standard deviation, then you can use a sample standard deviation as the best approximation for population standard deviation. So it is square root of n. What is n? N is 100. So what is here? N is 100. So now what I left with? I have to calculate z alpha by 2. So here it is 90%, correct? So it is 90%. So how much percentage I left with? 100 minus 90 is equal to 10% I left with. 10%, but this is alpha. But I want alpha by 2. How much? 10% by 2, how much? 5%. 5% means 0.05. That is why here it is given 0.05. Move to the normal table. In the normal table, go for the number near to 0.45. Oh, let me get back. It is 0.05. 0.05. How much will be the remaining from 0.5? 0.5. This will be 0.5 minus 0.05 equal to 0.45 will be the remaining probability I will be having. So here I will check for 0.45. Which number is very near to 0.45? I will be taking that number. It may not be approximately, but I will be taking it may not be accurately, but I will be taking the approximate one. Here I am getting two values, 0.4495, 0.4505. Both the differences are very near and the equal differences, and hence I am taking 1.6 and 4. 1.6 and 4. So what is my value? 1.64. 1.64. If they have given this value in the question, use it directly. Calculate this, and as I informed you many times, use this number 37.7 and then plus minus. Calculate this separately with your calculator. Write your answer, and then write your final answer. And the margin of error is given by z alpha by 2 into sigma by root n. Calculate and write that answer as a margin of error. We will be moving to the next one, the confidence interval for the confidence interval for t-test. The confidence interval for t-test. Here just use the same idea whatever we discussed over there. Read the question. This is n is equal to 10, so n is equal to 10, which is less than 30 the threshold, and hence this is a small sample. If it is a small sample, it belongs to t-test. X bar is given, the standard deviation is given, use it, and normally distributed the assumption is given. Compute 95% of confidence interval for mu. T-test for 5% level is given by 2.262. So substitute these values, all these values that you know, this value you know, this value you know, these two values you know. Now the question is left. Now the question left with only the 2.262. Okay, 2.262. Get back and go for how much percentage we are having? 5%. Clear? 5%. If it is 5%, 5% by 2, which is 0.25. 0.25 we have to calculate. At where we have to use the 0.25. What is the n value? N value is 10. What is meant by df? Df is equal to n minus 1. What is it? 10 minus 1. 10 minus 1 means 9. So we have to calculate 0. That value at 9 df 0.25 say. So it is 9 df. So this is the one, 9 df with 0.25, with 0.25. So what is the answer for us? 2.262. Take that value. So it is 2.262. As usual, write the first one, calculate the second one. Come on, write the first one plus calculate the second one, and then write the final answer. And as you know, the margin of the error is this part, and if it is separately, you can use it. The sample size determination. The formula is z table value into sigma divided by margin of error. Here it is given the margin of error is 1 and the required sample size is for 95% of confidence level, and here it is given the z value. Okay, standard deviation is 5. Substitute these values. Which value? The standard deviation is 5, the margin of error is 1, and what is the question now? It is z value 1.96. How we are getting 1.96 is the question now. So it is 95%, so it is 0.95. 0.95 divided by 2. 0.95 divided by 2. 47.5. That is 0.4750. Check for this value. 0.47. 47. What is that value? 4750. 4750. Yeah, it's a perfect value we are getting here. 0.4750. What is the value here? 1.96. So what is our answer? 1.96. So even if they have not given this value, then you have to go to the normal table and you have to find this answer and make the square. It is 96.04 and the answer is 97. You have to make it as a ceiling number, don't forget it. And the next part is to finding the p-value. For p-value, here we will be discussing 3 types. One is left tiled and right tiled and then two-sided. So it is negative 1.22. We have to calculate. So it is negative 1.22 or negative 1.22 means here z equal to 0, z equal to plus infinity, z equal to minus infinity. This is z equal to minus 1.22. What is the question? Less than. That is left tail. This is the left tail there. This is the right tail. So I want to calculate the less than probability. This probability I want to calculate. So probability of z is less than minus 1.22 I want to calculate. How to calculate it? I will be calculating it as 1 minus probability of z is greater than 1.22. So actually there are 2 methods. I am using only one method. What is greater than 1.22 from here to here, here to here, minus 1.22. So it is, let me put the bracket, probability of minus 1.22 less than z less than 0 plus probability of 0 less than z less than infinity, which is equal to 1 minus probability of 0 less than z less than 1.22 plus, close the bracket, plus probability of 0 less than z less than infinity. What is the answer? 1 minus plus 0.5. What is the value for 1.22? Go for your table. In the normal table, 1.22, 0.3888. So it is 0.3888 like that. And find this answer, which will be your final answer. It is a right-tailed test. Right-tailed test means this. Consider your normal distribution. This is z equal to 0 and here it is z equal to 1.43. I want to calculate this side. So it is probability of z is what I have to calculate greater than 1.43. Actually, see here also my objective is to calculate the minimal probability whichever is in this region, okay, not in the not in the accepting region, so it is greater than 1.43, which is equal to, how can I calculate? 1 minus probability of z is less than infinity. Again I am saying I am using the method 2, and you can use any method to get the respective probability. 1 minus, it is p of z is less than infinity. How can we write? Probability of, it is minus infinity, right? Minus infinity less than z less than 0 plus probability of 0 less than z less than 1.43, which is equal to 1 minus probability of, change it to positive and write the respective value, plus 1.43, 0 to 1.43. What is the value? If this is 1.4, this is 3, 4236, 0.4236 is not a p, right? And write your final answer. That's the p value for this one. And the next one, it is 0.84. It is for the two-tailed test. Two-tailed test means 0.84. What is the meaning? You have to calculate both the sides. So it is 0.84 minus 0.84, and here it is 0. So probability of, I want to calculate the probability between minus 0.84 less than z less than 0.84. So how can I write? Probability of 2 times of probability of 0 less than z less than 0.84. But I want this area, right? I want this area. How can I do? 1 minus, correct? So it is 1 minus. So is it 1 minus 2 into, what is probability of 0.84? Between 0 to 84, 0.8, here it is 4. What is the value? 0.2995. Calculate this and write your final answer as the p value for the two-sided test, this normal distribution. We will be moving to one sample z test. First, read the problem. Reading the problem is very important. It is greater than, it is given, so it is one-sided test. 29 days. A researcher wishes to test the claim that, so this is the claim. So the claim is greater than 29. So what is the null hypothesis? Mu equal to 29. And continue. A sample of 31 automobile dealers. So this is the value of n. So n is equal to 31. 31 is greater than 30. Greater than 30 means it is a large sample. Large sample means it is a z test. And has a mean of 30.1. So what is this answer? X bar, because it is a sample mean. A sample of automobile has a mean of, so it is the sample mean, and the standard deviation is given. It is a standard deviation of the population, so it is sigma, right? 3.8. Use the formula. It is x bar minus mu divided by sigma by root n. Use this formula and calculate your final. By substituting all these values in the rule, you will be getting some answer, 1.61. Okay, 1.61. Now if this value is given in the question, compare this with this value. For example, z calc equal to 1.61, which is less than z table. What is the z table value? 1.64. What is the meaning? Since this value is less than, we are rejecting h1, and you can write all the remaining whatever that is possible. And this is the traditional method. If you want to go for p-value method, the p-value method we have already calculated over here. Calculated over here. It is greater than, right? So if it is greater than, see what is your z calculated value? It is 1.61. This is the z calculated value. And what area you have to calculate? You want to calculate this area. So it is probability of z is greater than 1.64. So which is equal to 1 minus probability of z is less than 1.64, which is equal to 1 minus probability of minus infinity less than z less than 0 plus probability of 0 less than z less than 1.64, which is equal to 1 minus, change it to positive and write your answer 0.5, 1.61, right? 1.61. Change it to 1.61. So what is that 1.61 probability? 1.61 0.4463. Go to 0.4463. 0.4463, which is equal to 1 minus 0.9463. 0.9463. So the value, the final answer is 0.0 here it is 3 it is 5 so 0.0537. So what is your p value? The p value, the calculated, your calculated p value is 0.0537. What is their value? Their value is 5% level, right? So it is 5% level, 0.05 5% level. This value is greater. What is the meaning? Reject H0. Sorry, H1. Reject H1. Fine. And this is the difference between two means. Apply the same method, whatever that we discussed earlier, but it's only with the two. If it is with the two method, don't forget that it is not equal to the CV value may not be given. You have to calculate that CV value if it is not at a 5% level. So how to calculate the 5% level? We already discussed this in the earlier slides. Z calculation is 7.45. So how it will be? Probability of minus 7.45 less than Z less than 7.45. So what is this answer actually? This answer is entirely 1, right? Why? Because here at the 3.49 itself you will be getting 0.4998, which is almost equal to 0.5. So how much it will come? 0.5 plus 0.5, like that it will come, right? So it is 1, but I want the p value will be 1 minus, so it is 1 minus. So it is not 0, but it is almost equal to 0. What is the meaning? But the p value may be 0.000000172, like that it will come. But what is their value? Their value is 0.055%, right? 5%. So this value is lesser. What is the meaning? H0 is rejected. H0 is rejected. So here it is 7.45, which is less than 1.96, or sorry, greater than 1.96. What is the meaning? H0 is rejected. H0 is rejected, and you have to write all the rest of the conclusions as we discussed it in the class earlier. So it is a one sample t-test. One sample t-test and one sample z-test are same, except with the t value, the t value that you have to find out from the table. So it is n. So one sample z-test, application from medical or medical investigation, the number of infections per week at a hospital in southwestern peninsula is different from, right? So it is not equal to 16.3. So it is mu not equal to 16.3 is the claim. So what is this one? Mu equal to 16.3, a random sample of 10 weeks. So n is equal to 10. N is equal to 10 means this is less than 30. Less than 30 means small sample. Small sample means it is t-test. So we will be using t-test. X bar. What is X bar? So it is given a sample standard deviation is 1.8. So sample standard deviation is 1.8. What is the mean? 17.7. So it is 17.7. And use the formula. What is the formula? X bar minus mu divided by S by square root of n, and get the answer. The answer is 2.46. Substitute all these values and get your answer. So using the traditional method. So what is the traditional method? We have to find out the t value. How to find the t value? What is n? N is equal to 10, which implies what is df? Df is n minus 1. What is n minus 1? 10 minus 1. What is 10 minus 1? 9. So 9 df. How many percentage? 5%. Check out. This is df. Come on. This is df. In df 9%, it is two-tail test at a 5%. Okay. What is my value? 2.262. 2.262. So what is my t table value? 2.262. This value is greater. If it is greater, then you know the result. H0 is, what is it? Rejected or accepted? H0 is rejected. So it is a t calculated value. It is 2.46, and we have to find out. We have to find out. We have to find out the respective p value. We have to find out the respective p value. 2.46. So let me go for 2.46. Where is 2.4? It is 2.23, 2.4, 2.4. Yeah, where is 2.4? Come on, yeah. Where is 2.4? I'm searching. So yeah, I'm searching here. What the hell? So I have to search in normal distribution, right? 2.48. What is that value? 2.46. 2.46. So it is 2.46. 4931. 4931. 4931. 0.4931 into 2, almost 0.98, almost 0.98, 0.98. So we have to find the probability. Yeah, you can get it from where you can get it. Yeah, it is from normal distribution table. Normal table. Okay, and it is less than, you have to calculate. Yeah, it is 0.98. What is the remaining? 1 minus 0.98, which is 0.02. But I want it is two-sided, so it is multiply by 2 the remaining, and you will be getting 0.04 as your final answer. Yeah, it is that 0.04 is less than 0.05, and hence H naught is rejected. You are getting the same answer, right? And H naught is rejected. Okay, and if you want to find the outcome, yeah, it is 1 minus pt of this value. And for usually in the R programming, we will be giving the data instead of giving such a x bar and this value and all, because the objective of the R programming is to deal with the data, and it is there like this only it will be given. So they have given the x value, and we execute the t-test. How to execute the t-test? Yeah, the command is t.test, and store your answer in some result, or some result 1, result 2, something else. So the first one is yes, and the second one is null, because we are using one sample test. Alternative is less, because the question is less than, right? Because the question is, if the question is less, and mu equal to 40, it is given in the question. Pad equal to false, we don't have pad test. Variance dot equal to false, it is always confidence interval is 0.95, it will be given in the question. So after writing this, you have to execute that. If nothing is given, just to keep your confidence level as by default 0.95. And if you give names, you will be getting the full names. And after executing this, if you put dollar symbol, this is a dollar symbol. Okay, if you put dollar symbol, this will be displaying all the parameters, and whatever they are asking that in the question, you can choose that and you can get it with that. Under one sample t-test, it is a 2 sample t-test, right? It's a 2 sample t-test. Yeah, it is a 2 sample t-test. Keep this, and it is 2 samples t-test. Okay. Yeah, for the 2 sample t-test, it's the change is only in the formula. This is the formula. The formula has been already explained in the class, and even if it is negative, you can change it to positive and calculate this with the t-table value. Then the question is how to compare that with the table value. It is at a 5%. So what is n1? Read the question and get the value of n. What is n1? The sample sizes of 8 and 10, correct? So n1 and n2. So n1 is 8, n2 is 10. So what is df1? df1 is n1 minus 1. 8 minus 1, 7. What is df2? df2 is n2 minus 1. 10 minus 1, 9. Which number is smaller, 7 or 9? 7 is smaller, right? So go for 7. At which percentage? 5%. For 2-sided, always not equal to. So go to that value. Which value? 7df with 5%. 2.365 at 5%, right? 2.365. What is the answer over there? 2.365. 2.365 is the 2.365 is the value. Since it is two-sided, it is given negative and positive. Yeah, it is 2.365 as the CV. So this value is less than 2.365 and hence there is, we cannot reject the H0. And the remaining how to write that you know already. Yeah, it is a chi-square test. The one is normality and this is the table. This is the question. Okay, this is the question. A sample of 60 exam scores are taken. Their researcher want to test whether the data follows a normal distribution at half-life 0.05. Test whether the data are normally distributed. Usually, they will be giving you that value, chi-square value, right? The CV value they will be giving you. So, it is a class and observed expected probability they have given. Which is, what is the meaning? Either they can give this in percentage or something. So if they are not giving anything, you can simply take the average. But they have given some probability. Then how to calculate the expected? So it is 0.16 into find the total. What is the total over here? 45 plus 15, 60. So this much into 60. 0.68 into 60. 0.16 into 60. Okay, and write these answers. After writing these answers, use the formula. Which one? Which formula you have to use? This is O. This is E. Next, what you have to calculate? O minus E. Next, what you have to calculate? O minus E the whole square. Next, what you have to calculate? O minus E the whole square by E. Next, what you have to calculate? O minus E the whole square divided by E. And then find the total. And this is the total. What is the total? 1.4033. What value they have given? 5.991. How this 5.991 has come? 5.991. How this value has come? 2DF, correct? 2DF with a 5%. 5.991. 2DF with a 5%. How to? It is 1, it is 2, it is 3. So there are 3 rows minus 1 which is equal to 2DF. Okay. And like this also you can get that value, but usually the value will be given to you. If it is not given, get it. If the table is given, go to the table and find the value and then compare and write your decision. If it is less, if it is more, the H naught is rejected. If it is less, H1 is rejected. And the chi-square test for independence. How to calculate the independence? Whether is there any relationship between dependency between online and in class. And don't forget the H0 and H1 is always important for all the questions. So it is 12, 8, 6, 14 and you have to calculate the total. How much is the total? 16 plus 6, 12 plus 6, 18. So this is 22. So the total is 40. Yeah, the total is 40 and here it is 20, here it is 20. Calculate the total for the first one. That is, I am calculating the expected one now. Okay, I am calculating the expected one. What is this? 18 into 20. This 18, this 20 divided by 40. Calculate and write this answer. Like this, do for all the remaining or minus from the total to get your remaining answers. So what you are getting now? You are getting O. What is it? O? 12, 8, 6, 14. What is E? The E you already have calculated. What is that? The first one is 9. I have done this calculation, right? First one is 9. What is the second one? For example, 11. What is the third one? For example, 9. What is the next one? For example, 11. Okay. The total should be same. What is the total? 40 and 40. The total should be same. What you have to do next? Find O minus E. Find O minus E the whole square. Find O minus E the whole square divided by E and then calculate the total, and this total is the chi-square value. That chi-square value is given here. Okay, calculate this value and you have to find the CV. What is the CV? Either the CV value will be given or you have to calculate it from the table. What is the CV value? It is R minus 1 into C minus 1. What is R? Number of rows. 1, 2. Okay. 2 minus 1. What is C? Number of columns. 1, 2. So it is 2 minus 1. So 1 into 1 answer is 1 at a 5% level. So what is that value? What is that value? 1 DF at a 5% level. 3.841. 3.841. So this value is 3.841. Sorry, this value is 3.841. Okay. So it is 3.841. So what is your CV? What is your value? 3.63. 3.63 is less than 3.841. What is the meaning? H1 is rejected. Huh? We are unable to find any difference. We are unable to find any difference. And write all the remaining inferences. Next, program. So when giving the program, either 12, 8, 6, 14. This is observed. Okay. This is observed. This is observed. And you can go for chi-square test dot observed. This is the idea. But instead of giving the table, but because if you are giving the table, you have to make the data entry. So they may give such a program to generate this table. You got the point, right? Instead of giving the values directly, they can give you such a numbers, such a values as a program, such a values as a program. This is not as same, but it can be different also. So like this, instead of giving the table, they are giving that as a program to generate the table. So what is your objective? Chi-square dot test of the table. What is the table? The table is data 2. Okay, the table is data 2. Like this, you have to calculate. Just run it. If they are giving this, see, if they are giving us a table, make the data entry and then use the formula. If they are not giving, if they are giving this as a program, you are really gifted. Directly use chi-square data of observed. What is that observed? Data 2. Run this line and run this line, you will be getting your answer. The next one, ANOVA. In the ANOVA, you know, it's a very long program. We already discussed that in the classroom. This is SB. B means it is between, and it is SW. W means it is within the groups. WIT within the groups, right? For example, if you are having such a final table between within and total or something else, this is the sum of the squares. What is the sum of the squares? The answer of these two. And the DF, what is DF? Just now we have seen, right? K minus 1, n minus k, that part. Sorry, n minus 1, that part. So it is, here it is 2 and here it is 12. Then what will be the mean of the squares? What is the mean? Mean means divided, right? By the number of items. So 160.13 divided by 2. What is this answer? 104.80 divided by 12, 8.73. What is this answer? This answer is 80.07 divided by 8.73. You will be getting this answer. So what mistake you can do? You may wrongly put 8.73 divided by 80.07. If you calculate like this, your answer will be less than 1, which means that the F value is wrong. F value always greater than 1. So, and here is the program. As I told you, the y1, y2, y3 value may be given to you, and you have to combine everything. You have to repeat that, make the group, and then make it as a data frame. Make it as a data frame. This is very important, and these two are the final 2 lines. Instead of giving this, they can give you like this, because in the class I already explained. See, all these bracket, all these values, why we are doing? In order to create the data. In order to create the data in the required form. Instead of this, they can give you, instead of this, they can give you the program like this. Just run this program. After running this program, go for the last 3 lines. Make it as a data frame, fit ANOVA. Make it as a data frame, fit ANOVA. So you have to write, what is that? Data 1, for example, data dot frame of whatever it is, and then the fit line you have to write, and then print ANOVA of fit. And in the class I told you, either you can write summary of ANOVA also. Summary of ANOVA also you can write. So what you have to do? If they are giving such a data, write the full program. If they already give such a program, run this program and write only the last 3 lines or with the summary. That's enough. That's enough to get your answer. The correlation and regression, in the correlation and regression, this part will be given to you, and what you have to do, calculate x square, y square, xy, calculate all the totals, and use the formula for r, use the formula for bxy, use the formula for byx. Whatever is asked in the question, you have to answer. Okay, whatever is asked in the question, you have to answer. You don't want to answer all the things unnecessarily. How to write the program? COR of x comma y is for correlation, and LM of y tilde symbol x for regression. If it is a multi-regression, for example, they can ask you with 3 or 4 variables to predict one variable with respect to all the other variables, and hence it is LM of y with respect to all the remaining variables. Whatever they are asking, you can include here. And it is Wilcoxon signed rank test. Here, see, this is the red colors are the question, and they are asking you, is there any improvement in the question, and hence what is H0? There is no difference. What is H1? Yeah, there is an improvement, and that's the claim. So this is the question. So what you have to do, assign the ranks. What is the sorry I'm sorry, find the difference. What is the difference? Here it is 14 minus 10, 4, and here it is 3, here it is minus 1, here it is 2. Assign the ranks. So from the lower, this is the first rank, this is the second rank, this is third rank, this is fourth rank, and take the modulus, that is, sorry, remove the modulus and write this and assign the ranks. First rank, second rank, third rank, and fourth rank. I'm sorry about that. First remove the minus and write it, and then go for the ranks, and then sign the ranks. What is the signed rank? This is plus, write it as plus. This is plus, write it as plus. This is plus, write it as plus. This is minus, so write it as minus. So what you have to do? Calculate all the positive ranks, and then calculate all the sum of all the negative ranks. So what is it? 4 plus 3 plus 2, right? This is 9. This is 9. What is t minus? That is the remaining. That is only 1. So minus 1. So minus 1. What is the absolute rank? 1. That is minus 1, right? That is 1. So the test statistics is minimum of positive ranks and absolute negative rank. What is the first answer? 9. What is the second answer? 1. What is the minimum value? 1. What is the minimum value? 1. Usually they will be giving you the CR over here. The CR is 0. So it is 0. It is greater than, and then you can write the remaining calculations. For in the program, usually they will be giving you such a table, the data, right? This will be given. You have to write it in the form of perfect R programming vector form, and write the table with the appropriate parameters. So that's the task. And I'm sorry for the last one. It is somehow missed. So it is, yeah. Thank you all for your patience listening, and wish you all success. Have a great time. That's it from my side. Have a great time. Bye bye.